are going to study in this. It's a very interesting topic. So basically, it is also a branch of physical chemistry in which we are going to deal with the interconversion of chemical energy into electrical energy and electrical
Yes.
energy into chemical energy. So basically, we are going to study how we are going to convert chemical energy into electrical energy and electrical energy into chemical energy. Okay. So there will be cell that will convert chemical energy into electrical energy, and there will be cell that will convert electrical energy into chemical energy.
Chemical energy.
Very good. So write this point with me. It is the branch of physical chemistry. Physical chemistry, which deals with the interconversion, which deals with the, basically which deals with the study of interconversion of chemical energy into electrical energy, of chemical energy into electrical energy. So basically, there are two types of cell. One is galvanic or voltaic cell,
Yes.
and another is
Yes.
electrolytic cell. So basically, we have electrochemical cell, which is of two types: electrochemical cell that deals with the conversion of chemical energy into electrical energy, and and electrical energy into chemical energy. So
Chemical
yes,
energy.
electrochemical cell is of two types. The first one is basically we can call it galvanic or voltaic cell. And the second one is electrolytic. The second one is electrolytic. Now we will see in which cell chemical energy will be converted into electrical energy, and in which cell electrical energy will be converted into chemical energy. So here in galvanic cell, basically chemical energy converted into electrical energy. In galvanic cell, this chemical energy converted into electrical energy, and in electrolytic cell, electrical energy into chemical. Please let me know when you are done with this.
Yes, sir. Just sure.
And in both the cell, there will be redox reaction. In one of the cell, there will be a spontaneous redox reaction, and in another cell, there will be non-spontaneous redox reaction. But both are through, or both are via a redox reaction. Do you know what is a spontaneous and what is non-spontaneous?
So spontaneous means fast, right?
Spontaneous means fast, and non-spontaneous means slow, right?
I
Is
think,
this
yeah.
what you want to say?
No, like.
So basically, a spontaneous that occurs on its own. We don't need any external agent like pressure, temperature to occur that reaction or process. That process is called a spontaneous. And the non-spontaneous that requires external agent to occur, that is non-spontaneous. And a spontaneous is, yes, it is fast because it occurs its own. It's Let me know when you are done with this.
Yes. Done, sir.
So see which one is spontaneous and which one is not spontaneous. So basically, this is a spontaneous redox. This reaction or the process is a spontaneous redox reaction. And do you know how we are going to recognize whether it is a spontaneous or not? So basically, we define or we see with the help of Gibbs free energy, whenever the value of delta G is negative, that means the process or the reaction is a spontaneous, and this is basically non-spontaneous. This is basically non-spontaneous. And how we
So
are gonna
delta G is
recognize
Gibbs
whether it
free
is
energy, right?
non- Yes. If it is non-spontaneous reaction, that means delta, the value of delta G will be positive or greater than 0. What does this delta G stand for? Gives free energy.
Gibbs free energy.
Gives free. Please.
So you're lagging, sir.
Am I lagging?
Yes, sir, you are.
Oh, wait a minute, please.
Like in between your voice is going too slow.
Wait a minute. Am I still lagging?
No, so now you're not lagging, but in while explaining that.
That's why I just switched off my radio.
Yes.
Will that be okay for you?
Yes, sir, yes. Fine.
Okay, thank you. So, are you done with this?
Yes, sir.
Now, see,
So
we are going to.
just a minute. Can you just scroll up and write that Gibbs free energy code? Done, sir.
Very good. Now, we are going to learn about some terms that you already know. Like, do you know what is conductor?
Yes, sir. Anything that is in past.
What you just said? Anything?
That electricity can pass like a good
Yes.
substance. So
Can you
can you hear
give
me?
some example of conductors?
So metals.
Metals. Every metal.
Not every metal. Wait.
Yes, generally metals.
Most probably.
Yeah. So
Most.
basically, yes, substances which allow
Yes, electricity to pass.
electric current or electricity to flow through them. That is called conductors. Yes or no?
Yes, sir.
Very good. Please write it.
Okay.
And we can write also the examples.
Yes.
Examples are metals. Aqueous solution. AQ, that stands for aqueous.
Yes, sir.
Solution of acids, bases, and salts also. Acids, bases, and salts. Okay. So please write up to this and let me know. Then we are going to classify this conductor in two types.
Yes, sir. Done, sir.
Very good. See, there are two types of conductors. Two types of conductors. The first one is metallic conductors. Metallic conductor, which is also known as electronic conductor, which is also known as electronic conductor. And the second conductor is known as electrolytic conductor, electrolytic, or also known as ionic conductor. Have you ever heard of it?
Yes, sir, I have heard.
Okay, can you tell me the difference between these two? First, write it and then let me know what is the difference between these two. Are you done with this?
Yes, sir.
Can you tell me the difference between these two?
Yes, sir. Metallic conductors are conductors which have free electrons through which electricity can pass through them, right?
Yes.
And ionic conductors in which ions, which when electricity passes through ions in the solution.
When electricity passes through ions, it's not the good sentence that you are telling me. Basically, conduction is due to free electron in metal, and conduction is due to free ions in electrolytic cell. That's all.
Okay.
Are you getting my point?
Yes, sir.
So see, I'm going to differentiate between these two, which is very important, and questions has been asked from this topic. What is the difference between these two, or distinguish between these two? It's very important. So the first point I'm going to write is very easy to understand. So I'm going to write it first, then I'll explain. The conductor which conduct electric current by the movement of electrons without, this is very important point, without undergoing any chemical change, So the basically conduction is due to the presence of free electrons. You can write movement of free electrons, and without undergoing any chemical change. There will be no chemical change. Just suppose if you are going to pass current through iron, will there be any chemical change in iron? No chemical change. So basically, metallic conductors are those which conduct electricity due to the free movement of electrons without any without undergoing any chemical change. Now, when we talk about electrolytic conductor, so basically the substance or the conductor which conduct electric current, which conduct electric current through ions in a solution, through ions, with the help of ions in a solution or in molten state are called electrolytic conductor. When we will do electrolysis, you will see what is all this. Example, we can write metals, we already know. Non-metals like graphite. Non-metals, in non-metals, graphite conduct electricity. It is allotrope of carbon, which is non-metal, copper, Ag, Fe, aluminium, etc. And here we can write basically NH3, ammonia, NaCl, H2SO4, HNO3, NaOH, HCl, etc. Please write. So this is a small definition. Basically, we will distinguish in the next step. So I didn't ask you because last class you were absent.
Yes, sir.
What is the syllabus what is the syllabus in your upcoming exams?
It is sir electrochemistry and this alcohol phenols.
Oh, that means 2 chapters. And when this exams gonna held?
Sir, exam starts on 2nd, but let me just check on the chemistry one. When is it?
Okay.
I think it is last. It is on 6th or something.
6th October?
Yeah.
That means we need to cover up the syllabus before that.
Yeah, it is on 6th, sir.
So this is also a lengthy chapter, so you should take some extra
sir,
classes.
In school also, sir, we are doing this, but I don't think we'll cover it. Yeah. So they must keep half a chapter or something like that.
Okay, actually we just started the electric part, not from the starting. After this, we will go for Coulomb law and all. We just in the next class we will just complete the electric part. Then
yeah. So in this chapter, in the first point, we're doing dynamics, right? Today's class.
Yeah. After this, after Coulomb law, which is very important.
Yes, sir.
In 2 classes we will be at Coulomb law. Are you done with this?
So just now I'm writing the electrolytic conductor.
Good.
I'm done, sir.
Done. Very good. Now see, this electrolytic conductor is further divided into 2 parts. So I'm just going to write 2 types of electrolytic conductor. 2 types of electrolytic conductor. Now see, what is this two type of electrolytic conductor? Basically, the first one is a strong electrolyte. A strong electrolyte. Wait a minute. Just write two types of electrolyte. Or after that, we will see for electrolytic conductor. The first one is basically a strong electrolyte, and the second one is weak electrolyte. What is a strong electrolyte? So basically, this strong electrolyte means it will dissociate into 100%. Basically, ions will be 100%. So basically, we can write electrolytes which are completely ionized in aqueous solution. In aqueous solution, completely ionized, that means almost 100% dissociation will take place, are called strong electrolytes. If you are going for example, it's very easy to understand the example. Generally, a strong acid, a strong base, salt, a strong acid, a strong base, these are all a strong electrolyte. Also, salt like NaCl, you can take a strong acid like HCl, HNO3, HBr, HI, and a strong base like NaOH, calcium hydroxide, like this, etc. And what is weak electrolyte? That means weak electrolyte that will not 100% dissociated, only 5% dissociation will take place, almost 5 to 10%. That is weak electrolyte, or you can call it basically partial dissociation. So I can write a definition for this: electrolytes which dissociates or which are not completely dissociated, which are not completely ionized, completely ionized in aqueous solution. In aqueous solution are called weak electrolytes. Are called weak electrolytes. Please write it and let me know if you have any doubt in this.
Yes, yes.
I'll give the examples. Basically, generally, organic acids and organic bases are weak electrolyte. They do not dissociate 100%.
Done, sir.
Very good. Okay. So I'm going to take example of this also. So please write it. The examples are
Organic,
generally
organic bases.
organic acid and organic bases.
Organic.
Organic
Yes, sir.
acids. Organic acids
Sir,
like you can say carboxylic acid, CH3, COOH, ethanoic acid, methanoic acid, and organic bases like methanamine and etc. This. Okay.
yes, sir. Done, sir.
Very good. Now we are going to now differentiate. Are you done with this?
Yes, sir. Yes, done, sir. Done.
Very good. Now we are going to differentiate between, distinguish between these two. These two, that means basically metallic conductor and electrolytic conductor. So metallic conductor, and here I'm going to write electrolytic conductor. Electrolytic conductor. So now the first point about this is charge carriers. Charge carriers are free electron. And the first point about this, charge carriers are free ions. Charge carriers are free ions. Free ions. Second point we can write flow of electricity. Flow of electricity takes place without chemical change, without any chemical change, without any chemical change. And when you are going to talk about this, so flow of electricity takes place by chemical change, by chemical changes at electrode. We will see how the chemical changes will take place at electrodes. And the third point we can write, no transfer of matter takes place. There will be no transfer of matter takes place. You have seen that if you are going to pass current through iron, will there any be will there any transfer of matter takes place? Yes or no?
Sir, you're lagging.
What I was asking is,
Sir, can you hear me? You're lagging.
yes. Am I lagging? Yes, I am. Are you there?
Yes, sir.
Am I audible now clearly?
Yeah, and now you're audible.
Okay, sorry. So what
Yes,
I
sir,
was
what are you
asking,
asking?
yes, I was asking that if you are going to pass current through iron, will there any transfer of matter takes place?
Transfer of matter? No.
Yes, no.
Yes.
So that's why in metallic conductor, no transfer of matter takes place, but transfer of.
So, like, if we pass electricity to ions, transfer of matter take place.
No.
Okay.
Because if you have this rod and you are going, this rod is of iron and you are going to pass electric current, will there be any transfer of matter takes place? Like, will this be in future? This will be thin and thicker, or thicker or thicker? This will be as it is.
No.
So that means, are you getting my point?
Yes, sir. Yes, I got it.
So that's why basically matter does not take place, transfer of matter. Now here you can see transfer of matter takes place. In electrolytic conductor, transfer of matter takes place in the form of ions. in the form of
Ions.
ions. Basically, you know what happens there. There is only movement of electron, free electron, and the mass of electron, we take it negligible. Are you getting my point?
Yes, sir.
But here, movement of or flow of ions take place. That means all the atoms, basically ions are moving. That's why in the form of ions, matter transfer of matter takes place. Got it?
Yes, sir.
The last point is very important. Faraday's laws of electrolysis. Faraday's laws of electrolysis are not followed. Are not followed.
Followed.
In this, Faraday's law of electrolysis are not followed. But here, Faraday's law of electrolysis are followed. Simple.
Okay.
So please write.
Yes, sir. Done, sir.
Very good. Now see, I'm going to introduce pure reductive part here. So write the topic, that is electrolytic conductance. What it is? Electrolytic conductance. And the first term we are going to introduce here, you all already aware of that, a resistance. So do you know what is resistance? You have studied this in current electricity.
Yes, sir. It is the ability of an object to resist the flow of electricity.
So basically, property of any substance or the conductor which resists the flow of current.
Yes,
so
sir.
we can write with me. The property of conductor which resists the flow of current is called resistance. So from Ohm's law, you already know. From Ohm's law, have you heard of it? You
Yes,
have
sir.
heard
V
of
is
it
equal
from
to
class 10. Yes, Ohm's law. You already know that V is equal to IR. So
yes,
what will be the
potential is
formula
equal
of
to current
resistance?
into
Resistance, this resistance is denoted by R. R will be equal to V upon I.
V by
And
I.
do you know what is the SI unit of resistance? SI unit of?
Oh, yes, sir. Ohm, right? No, so wait.
Ohm. Very good.
Yeah,
Yes.
Ohm, right? It's Ohm.
Be confident.
Yeah.
It is Ohm and denoted by basically. I'm going to write. It is Ohm and it is denoted by this. This is. Yes.
Yes, sir.
So please write it, and then another topic, conductance, which is denoted by G. G. You are going to cover each and every question from NCERT because I want you to score full marks.
So, done, sir.
Very good. Am I audible clearly?
Yes, sir. You're audible, sir.
Very good. So do you know what is conductance?
Yes, sir.
Do you know what is conductance? To conduct electricity. Basically,
yes, sir,
it is
yes,
inverse or reverse of resistance. So we can write it is
resistance. Yeah.
it is
Flow of
reciprocal
current.
of reciprocal of, we defined it as reciprocal of
Resistance.
reciprocal
Yes,
of resistance. And do you know the formula from this statement? We can write a mathematical equation.
1
that
by
is,
R is equal.
now can you tell me about the unit? Unit of conductance will be per ohm.
Per ohm, right?
Per ohm.
Inverse
This
of
is known as,
yeah.
yes, per ohm. Or we can also write ohm inverse, or also known as MHO. That will be that has a symbol opposite of ohm.
Yes,
And
sir.
also known as, per ohm is also known as Siemens, that is denoted by S. So all are the units that are related to each other. Per ohm, and per ohm is also known as MHO, that is the symbol will be opposite, and then Siemens.
Done, sir.
Very good. Wait a minute. Yes. Is it done?
Yes, sir.
Very good. So this is resistance and then conductance. Then another terms come. That is known. That is basically a specific resistance. A specific resistance, and also known as resistivity, and also known as resistivity.
Resistivity.
You are aware of this term also.
Yes, I am.
What it is? It is basically represented by. It is represented by rho. This is the representation Rx rho. Rho.
Yes, sir.
And how we are gonna define it?
Yes, sir.
The resistance.
Sir, a measure of resisting current?
We will see. Basically, it is property of conductor. Resistance R of a conductor is directly proportional to length of the conductor.
Yes, sir.
Length of the conductor. That means L, and
Temporary.
inversely proportional to. Inversely
Proportional.
proportional to area of the cross section.
Area of cross
Area
section.
of cross section. Area of cross section of conductor. So this is it. So see what happens basically. R is directly proportional to length of conductor. R is inversely proportional to area of conductor. That means if you are going to increase the length of the wire, resistance also increases.
Yes.
And if you are going to increase the area of cross section, that means you are taking thick wire, then resistance will decrease. That means more current will flow from there. Combining these two equations, you will get L by A. And to remove this proportionality sign, we are gonna take rho L by
Rho L by A. Yes, sir.
And do you know, for a specific particular matter, resistivity is constant.
Done, sir.
Very good. Now, can you find the unit of resistivity?
Yes, sir. Just a minute. Just a minute.
Okay.
Unit of resistivity.
Yes.
Sir, what is it? Forgot it. I forgot it.
You have the formula, you can derive it easily. See how we are going to derive it.
It
So
is.
from this formula, we can write a
Sorry, it
formula.
is area means meter and
R into A by L. Can I write
yes.
this? And as you know that,
Yeah. Yes.
as you know, this has a resistance R, area as a meter square.
What is
So
ohm meter
this will
square?
have meter. Meter and meter will be cancelled.
Yeah.
So
Ohm
the
meter.
unit will be ohm meter or ohm
Meter.
centimeter. That depends.
Yes, sir. Done, sir.
Very good. So this was about resistivity. Now we have another term that is known as a specific. No, we have already done this. Yes, this is known as a specific conductance, or commonly called conductivity. Conductivity. And this is denoted by a letter like K that is known as kappa.
Kappa.
Kappa. Yes. And do you know what it is? It is reciprocal of resistivity. So we can write it is defined as reciprocal of a specific resistance. A specific resistance or resistivity. A specific resistance or resistivity. So we can have a formula. Kappa is equal to mathematical equation 1 upon
1 by rho.
So can you please tell me the unit of kappa?
Yes, sir.
Unit of kappa. Please write.
Sir, it is Siemens, right?
No, not Siemens.
Sir, in class, my teacher told me to Siemens.
What is the unit of rho? We already know that this is ohm, centimeter or ohm meter. Yes or no?
Yes.
So do you, I can write also 1 upon ohm into 1 by centimeter. And 1 upon ohm can we write per ohm per centimeter.
Yeah.
And this per centimeter is Siemens per centimeter. And this per ohm is also known as mho per centimeter we can write. Are you getting my point?
Yes. So like I was after adding a centimeter, Siemens.
Not only Siemens.
Yeah, it's not only Siemens, Siemens per centimeter.
Yes.
Done, sir.
Done. Very good. Now see, we will have another term that is basically cell constant. So you already know R is equal to rho L by A. Yes or no?
Yes, yes.
Now can I write rho is equal to? Can I write rho is equal to R into A upon
A
L?
by L.
Can I write it? Now
Yes, sir.
I'm going to take inverse of this. I'm going to take inverse of this. So taking a reciprocal of above equation, reciprocal of above equation, taking reciprocal of above equation, 1 by rho will be equal to L will be above in numerator, A will be in denominator, as well as, no, wait a minute, what I just wrote is 1 by R, and this will be 1 by R. Can I write this? Whatever
Yes.
will be in numerator will come into denominator, and whatever will be in denominator will come to numerator. Yes or no?
Yes, sir.
So now you know that 1 by rho is known as basically what? 1 by rho is kappa. Can I write this?
Yes.
This quantity. And 1 by R is basically conductance. So can I write G?
G.
And do you know what is L by A? I will define it. This is known as cell constant
Cell
G star.
constant.
G star. We write G star for G, cell constant. This is basically cell constant.
Yes, sir.
Length of conductor per unit area of cross section of the conductor is called cell constant. Okay, so I am going to write length of conductor per unit area of cross section, area of cross section of conductor. That is basically cell constant and is denoted by G star. Can I write this?
Yes, sir.
This is it. Please write it. So we can write conductivity is equal to conductance into cell constant.
So just a minute, sir. Done, sir.
Very good.
So just a moment, my internet is lagging. Just a minute, sir. 1 minute.
Okay.
Yes, sir. You can continue, sir.
Very good. So can you find the unit of kappa? Oh, we have already
Sir,
done.
you done, sir. Unit of kappa is done.
Yeah.
It
I
was
thought
Siemens
we were-
centimeters per centimeter. Siemens per centimeter.
Siemens percentage. That's good.
Yes, sir.
That's good. Now see, we have another term which is very important: molar conductivity or
Okay.
molar conductance. Molar conductance.
Yes.
This is basically related to. This is basically related to molarity. So you are all already aware of molarity from solution chapter,
Yes.
and it is denoted by lambda m, or sometimes in some books it is denoted by mu. So first of all, I'm going to write about it. It is defined as the conductance. It is defined as the conductance of all the ions produced by 1 mole of, basically it is molar, so we will see in 1 mole only. It is conductance due to all the ions present in 1 mole of oh, 1 mole of electrolyte present in the given solids,
Solution.
So basically we see the conductance present in 1 mole of electrolyte by all the ions. That is called molar conductivity or molar conductance. And we have a formula: lambda m is equal to kappa, that is conductivity, into volume v. If you are going to increase the volume, that means the distance between the particles will increase, yes or no?
Yes, sir.
And if the distance between the particles will increase, the force of attraction between the particles increases or decreases?
Distance between, sir, it will decrease, right?
If the distance
No,
between the
if
particles,
distance increases, the force will
force of attraction
increase.
decreases.
Will increase. Yeah.
No. What you am saying? Have you heard of Coulomb's law?
Yes, sir.
If two
Just
charges
last.
are placed, if there is force of attraction, and if they are
Yeah.
placed nearby, so in which the force of attraction will be high? The above
Yeah.
one, F1 or F2? What do you think?
F1.
F1, because force of
They're close to
attraction
each
is
other.
inversely proportional to each other.
Distance.
Yes, the force of attraction is inversely proportional to the distance. Are you getting my point?
Yes, sir. Got it.
See, so if you are going to increase the volume, that means if volume increases, the particles will go far away from each other. If you are increasing the volume,
Yes, sir.
particles will be far away from each other. Just suppose
Yes.
this is the container. The particles are like this much distance. If you are going to increase the container, the volume of container, the particles will be far away from each other or not?
Yes.
So if the particles will be far away from each other, that means force of attraction decreases. Yes or no? Please do reply.
So can you repeat the question? You were lagging for me. Sorry.
Am I lagging again?
Yeah, yeah. Increasing the volume, the distance between particle increases.
Increases. If the distance between the particles increases, force of attraction decreases.
Will decrease.
If the force of attraction decreases, that means this particle can move more freely or fast.
Yes, yes, sir.
So if they will move fast, that means they will conduct easily more and more.
Yes, yes, sir. Because they're free then.
Yes, that's. Now, please write it, then I will go ahead.
Done, sir.
Very good. Now see, if the volume is V, if we are taking V volume of solution containing 1 mole of electrolyte. If concentration of solution is m mole per liter, then do you know molarity has a formula, number of moles of solute upon volume of solution in liter?
But volume of solution.
So we will get lambda m will be equal to kappa into 1000.
Okay.
Upon m. This will be the formula for molar conductivity. And you know what will be the unit? Unit will be per ohm per ohm centimeter square per ohm centimeter square per mole, or we can write Siemens per Siemens centimeter square per mole, or we can write Mho centimeter square per mole.
Okay.
Please write this.
Yes. Done, sir.
Very good. Now see, we have the next term, that is equivalent conductivity of equivalent conductance, that is denoted by lambda eq or this. So I'm going to define it in the same way as above one. It is defined as conductance of all the ions, conductance of all the ions produced by 1 gram equivalent of, since we are talking about equivalent, so in the previous one, molar conductivity in 1 mole of electrolyte. Now it is equivalent conductivity, so produced by 1 gram equivalent of electrolyte in the solution, in the given volume of solution, in the given volume of solution. Now you can see that lambda EQ will have the same formula, kappa into volume. And then again, if V is equal to, this V is equal to volume of solution containing 1 gram equivalent of electrolyte, 1 gram equivalent of electrolyte. And if concentration, since we are talking about equivalent, so we will take normality. If concentration of solution is n gram equivalent per liter, then please write
Done, sir.
very. So you can see if it is so, so we will get a formula lambda EQ is equal to kappa into 1000 upon n. That is normality. That is normality. And its unit will be as same as that, per ohm centimeter square per equivalent, because we are talking about normality, and Siemens centimeter square per equivalent. Please write it.
Yes, sir. Done, sir.
Very good. Now write a relation between lambda EQ and lambda n. That means
Okay.
basically molar conductivity and equivalent conductivity. So relation between molar conductivity, this is not n, molar conductivity and equivalent conductivity and molar conductivity. So you already know that lambda m is equal to kappa into 1000 upon n, and lambda EQ is equal to kappa into 1000 upon n. Now you can see basically we know that from solution, normality is equal to molarity into n factor or valency factor. Do you remember the value of x? Equivalent weight. So lambda EQ, after putting the value lambda EQ, you will get lambda m upon valence factor. So whenever you need to change from one place to another, you will be needing this release.
Yes, sir.
In solution chapter, the first chapter we studied, I showed you that how to calculate valence factor for acid, base, and salt. If you remember,
Yes, sir.
please write it.
Yes, sir. So can you say what is V here? Oh, valence factor.
Valence.
Yeah, valence factor. Sorry. Done, sir.
Very good. So write a question with me. This is homework. Okay.
Yes.
The resistance of 1 solution of salt is 50. Calculate the equivalent conductance of the solution. If the two leading electrodes in solution are 2.1 centimeter apart and each having an area of 4.2 centimeters.
Yes, sir.
Done. So I
Yeah, I
will
wrote the
see you in
question.
the next class. Okay.
Okay. Okay.
Please do this. And after this,
Yeah.
some questions, we are going to study about the variation of molar conductivity and equivalent conductivity. And after
Okay.
that, we will start Coulomb law. And in the next class, we will only complete Coulomb law because it is very important and we have to do a lot of questions.
Okay.
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 And after the next class, we will go for galvanic cell and diodes. Okay, that you were talking about. Okay.
Daniel cell. Yes.
Yeah.